Hey, what's going on, guys? CodeMonkeyGames here. In this video we're gonna start implementing our move generator, believe it or not, and we'll start with generating pawn moves. So there are two kind of moves in chess: quiet moves and captures. And if we talk about like pieces that are not pawns, there is not much difference between the moves that are either captures or non-captures. But in case of pawns can move only forwards to make a quiet move, and they can capture only diagonally. So let's have a look at the basic pawn moves. So we can move pawn one square ahead, which would be the offset of 16, assuming the hexadecimal 88 board representation. We can also have double pawn move, only in case if the pawn is located on the rank 2 for white pieces and on the rank 7 for black pieces. And another thing to consider would be the pawn promotion. So if say we replace so let's have a look, let's replace this kind of pawn with a white pawn. Okay, so also we can promote pawn to queen, rook, bishop and knight respectively. So, and also we can capture, so also we can get our piece promoted while capturing something. So we can also capture and get this piece promoted. So this is it regarding the pawn moves. And there would be two parts for the pawn move generation. So the first video of this one in particular would be generating the quiet pawn moves, while the next part would contain generating pawn capture moves. So if you're interested, let's actually start writing some code. So last video we did end up with specifying our print attack squares function and implementing the is_squares attacks function to answer the question whether the current given square is actually attacked by the given site. And in this and now we'll just move on basically. So we don't really need this to print this attack map anymore, and I just want to replace the FEN with this tricky position, which is known as a tricky position. And I'm not using the tricky position variable because we would be altering this slide a little bit. So in order to avoid ruining the initial tricky position, which is the very beginning of our source file right over in here. Okay, so let's try to print our board. Okay, we got this tricky position, and now we can already specify the function that is called generate moves. So let's call this like move generator, and here we can define the void function called generate moves. Okay, and as far as this is the void function, it's not going to be returning any values. So the very first thing to consider, we need to loop over all board squares, and in order to do this I need to say for in square equals to 0 and square is less than 120, the length of our board array, and finally square plus plus. Okay, and we also need to distinguish if the square is actually located on board. So that's the reason for looping only over those squares that actually are located on the board. So let's say check if the square is on board. So here I can simply say if and not square bitwise ended with the hexadecimal 88, our standard way to represent to answer the question whether the square is on board actually or not. And also we need to take care of the site to move. So but obviously, yeah, so just hold on a sec. I'm just So there would be a little bit difference between the pawn moves implementation and pawn and castling move implementation and the rest of other moves. So just to specify the pawn moves, we also need to check the side. So let's say like check the side to move. Well, let's say if white to move, or how to make this. Oh, let's say actually white pawn moves, and here I can say if and not side, which is equal, that side is equal to 0. In this case, this represents the white side to move. So if not side, or otherwise we can say if side is equal to white, which is literally the same, but it's just the shortcut for this is just to say like if not side. And we will also have this else clause here, and here we would be generating not, well, by the way, not only pawn moves. Well, let's say one white pawn moves and castling. Let's say white pawn and castling moves, and here we would have black pawn and castling moves. Okay, so this is it. Okay, and among both white and black pawn moves, we would have quiet moves, so quiet pawn moves, and also we would have capture pawn moves. But first, well, let's actually try to get down with our quiet pawn moves. Okay, I'm just thinking where it would be better to start here. Just hold on a sec, guys. Okay, so we can say if board indexed by the current square is actually equal to big P, which stands for the white pawn code here. So in this case, we'll need to generate pawn promotions, and also we'll need to generate one square ahead pawn move and two squares ahead pawn move, like this. So here we need to answer the simple question, so we'll just comment this out for a while. So pawn promotions, and hold on a sec, probably I forgot one little thing here. So before specifying this, guys, we also need to make sure that the target square is actually supposed to be on board. So check if target square is on board. So in order to do this, we need to say if, and we need to say square plus 16, sorry, not plus 16 but minus 16, because we have, so let's have a look at our indexes. I'll just show you this right at the moment. So we got this, so white pawns are located here and they go in kind of upwards, but from the index perspective it would be like, so to get this value out of this, we need to subtract something, to subtract the offset of 16 from this sort of an index. So 96 minus 16 would be 80. 80 minus 16 would be 64, and so on and so on. So that's the reason. So in order to calculate the target square for a given square, we need to subtract the offset from the source square, and to ask whether the target square index is actually on board or not. So that's the reason to ask here, like, so square minus 16 bitwise ended with a hexadecimal 88. So if all of this stuff is actually if it is equal to 0, so or other words, if this is on board, in this case we want to do all the stuff ahead basically. But obviously we also need to ask whether the target square is empty or not, because you can't really move the pawn forwards like in this case, because you see like the target square contains something on it. It doesn't matter whether this is a white piece or a black piece. So in order to move the pawn forwards, okay, so we just need to move back this slightly bit. So in order to move the pawn forwards, we need to have this square being empty, so we can't move this line. We can move only to those squares that are empty. Okay, so we want to ask if board indexed by square minus 16 is actually empty. So we can either say like equals to 0, or just the shortcut for this, just to say if not, board square minus 16. So if this square is empty basically. Okay, let's try to compile run this to see if I didn't ruin anything. Okay, so for square, did I? Yeah, just sorry, semicolon, not the comma. Okay, it seems like to be working just quite pretty nicely. Okay, and so generating. I'm just want to print the from squares basically. So before anything else, let me just try to print my from squares. So this would be, we have this square to coordinates array and indexed by the square, and here I just want to print this s followed by the u line. Okay, so let's have a look. Okay, sorry, just something. Just let me first try to print this right over in here to make sure that we do. Okay. Oh, I didn't yet call this generate moves function here. That's the reason. So generate moves. Okay. Yeah. So the side to move is white, and here are the pawns. So we got this d5. And we got this e4. Okay, for some reason e4 is not being printed. Well, it's not being printed because it's not going anywhere basically, so that's the reason. So just to show you, if I would have print not here, but instead if I would have print here, so every time we match the white pawn, this would give us all the from squares containing the pawns. So we have this d5, there is a pawn on it, e4, there is a pawn on it, a2 b2 c2, a2 b2 c2, and also f2 g2 h2. So these guys, but as far as this pawn is not really moving anywhere because there is a piece standing in front of it, so we're not really printed as a from square. So just to make it a little bit more clear. Okay, anyway, I just want to get rid of this line, and okay, and bring it back right over in here. Well, I can actually okay, so just let's drop this print statement for now, just put this to another place. Okay, so we need to make sure that the pawn that is supposed to be promoted is actually located on the 7th rank, if we are talking about the white pieces. So let's have a look at our board. So this is the 7th rank. Only if pawn is located just right over in here. Only in this case it can't get promoted basically. So that means that we need to specify the condition answering the question whether the pawn is located on the 7th rank. So how to make this? So it means, so I just want to show you this one little thing here. So let's try to print f, and I want to print a7 right? And here I say A7 and the decimal to show kind of what square index is associated with the A7. So it's index of 16, and now let's print absolutely the same value but for our H7. So H7 and H7 respectively. Okay, so we got this 23. So whatever whatever square in range from 16 up to 23 is considered to be the 7th rank. So that's exactly the way how to specify our condition. So we can say if the square is greater or equals than A7 and less or equals than H7. In this case, we make sure that the pawn is located on the 7th rank. So just to make it a little bit more clear, now we can here within the pawn promotions we can give this condition basically. So we can say like if square is greater or equals to A7 and square less and or equals than H7. Okay, and let's already start making use of our print statement to at least try to define our source squares for the pawns. Just hold on a sec. See, so now we won't be printing anything because we don't really have the pawns on this 7th rank. But let's try to say make this pawn to be white. So it's 3rd one, yeah. So this one, let's make it a white pawn. And suddenly we got this C7 being printed because we can't promote this already. And say we convert this pawn, so instead of the queen, let's have another pawn. So this shouldn't be considered because it's not really going anywhere, right? Okay, so now we have 4 options, exactly 4 options. So let's print this from square. Let's also print the to square, so the target square where this pawn is supposed to be going. And the target square would be square to coordinates and square well, we could have actually defined this target square slightly bit earlier. Yeah, I guess this might be a good idea. Okay, yeah, so just let me just try this and then we'll go further on. So minus 16, right? And we can promote to queen, right? C7, C8 and goes to queen. And okay, so what I want to say here, so we can initialize our target square. So let's create the integer called to square, and this would be equal square minus 16. So to specify this kind of once and forever. Okay, and well, I guess we also can specify I guess we can also specify this ranks as well to prettify code slightly a bit. But yeah, let's drop it. So we can now say if board actually to square, okay, is empty, and here again board equals like to square. So make sure we're dealing with the target square there. Okay, copy, and there are 4 options available, so we can convert. We can promote to queen, to rook, to bishop, and promote to knight as well. So now it should print 4 moves. Perfect. So these moves would be later on added to the move list, and that's a wide topic to discuss and to implement. But for now, we just want to use these print statements as the placeholders for moves that are being generated. So we got this pawn promotions, which is quite pretty perfect. Okay, so the next thing to consider, so else, I can say like else, so all the other cases doesn't really regard to dealing with the pawn promotion, so all the other cases are about to be handled within this else statement. So one square pawn move, and here so we already did make sure that we actually do have this 2 square on board, and we don't really have anything there, so we can simply use our print statement just as the placeholder to specify the move. The only difference that we don't really need to promote this anywhere, so let's make sure that this moves are generated as well. So what we have this c7 to queen, rook, bishop, knight promotions, which is right. Then we have the d5 pawn, and it goes to d6 and nowhere else. Then we have this e4 square, which is not moving anywhere, hence is not available. Then we have this a2, b2, and g2. So a2 goes to a3, b2 goes to b3, c2 is not going anywhere because there is a knight standing. Now we got this g2 square, g2 pawn, which is going to g3. But obviously there are a couple more moves available in this position, and in particular these moves are a2, a4, double pawn move, and also g2, g4. Okay, so we need to specify the case to generate these moves as well. So here we can say if, and a couple of conditions. So the first condition, we need to make sure that this particular pawn is located not on the 7th but now on the 2nd rank. So double pawn move due to the chess rules is possible only for those pawns that are standing on the 2nd rank. So this pawn, they are not able to make a double pawn move. So only this guy is standing on their initial position, exactly on the rank number 2. So here I specify if the square is actually is located within the range from a2 to h2, which is the rank 2. And we need another condition here. We need to make sure that the target square, and this time this would be square plus. So I could have actually defined this to square like for a double pawn move, but I won't really be doing this. So I can simply say if empty, so if nothing, at board and square minus 32, and this 32 stands for kind of double index, double offset there. So now we should print our moves for double pawn moves. So let's just, so yeah, and here not the 2 square obviously, but again we have this square minus 32. So when I would be copy pasting this, it's incredibly important not to forget to actually change this minuses to pluses for the opposite direction of moving pawns. Okay, so okay, did I do something wrong? Okay, something wrong with my board. Oh, a board square minus 32. Yeah. Okay, so now we got this a2, a3, and a2, a4 being generated. We have b2, b3, yeah, but we don't have b2, b4 because there is a piece standing regardless of color, and we have this g2, g3, and g2, g4. Okay, so also we don't have the moves, move options for h pawn because just pawn standing in front of it. Okay, so it seems like that the white pawn moves are generated correctly, and this is the good news in general. Obviously, what I'm doing now is not the way to test the move generator, and we would be writing the perf test, also known as performance test. Performance test, also known as the perf test among the chess program developers, chess engine developers, which is the way to heavily test the move generator in general, and if any bugs would occur regarding the pawn move or whatever move generations, they would be revealed right over there, and that's the main pain during writing your own chess engine, when you need to debug all these tiny little conditions, because if you make an only single mistake already, you won't pass the perf test, and your engine is doomed to be kind of buggy, and you're not really going anywhere with that. And by the way, it took me for about 3 years to create my very first bug-free move generator, believe it or not. So it's quite pretty complicated to achieve, but still I hope that, even though I'm doing this from scratch with some kind of new values here, so I did this. I did write lots of chess engines, but still never did them like exactly the way I'm doing this right now, basically. Okay, so as far as it seems like the quiet pawn moves for white pawns works quite pretty nicely, we now need to do literally the same for the black pawn. So here, quiet white pawn moves. And I just grab this entire code here and just copy this and go into the else clause where we're dealing with the black pawns and black gains when this would regard to castling moves. So now we need to match the black pawn. Okay, the 2 square would be plus 16, right? Okay, actually I did forget to replace this 2 square in one more place, so here I can say, here I can use this 2 square bitwise ended with the hexadecimal int A to make sure that it is on board. Okay, so here we can use 2 square. Okay, and for the promotions, it's literally on the contrary, so we want to make sure that the black pawn is located on the 2nd rank if it's about to get promoted, right? And in case of double pawn moves, we need to make sure it's actually located on the 7th rank. So just like how it visually is, basically. So the 7th rank, only from here black pawn can make double pawn moves, and only from here they can kind of promote. So just to bear that in mind. Also, we need to shift the direction of moving pawns from one side to another, so not minus 32 for the double pawn moves, but plus 32 instead. And well, hope I didn't miss anything, because this copy pasting usually ends up with lots of bugs, but I hope I didn't yet ruin anything here. So I just want to run this one more time to make sure that the white pawn moves are still generated correctly, and it seems like they are. Okay, so now we can bring the black pawn here as it was initially. So we have only d5, d6, a2, a3, a2, a4, b2, b3, g2, g3, g4. Okay, perfect. So now we can shift the site. So instead of generating moves for white pieces, we can now generate moves for black pieces. Save. And let's have a look. So we got this c7 pawn, so c7, c6, c7, c5, which is right, d7, d6, which is right, g6, g5, which is right, and b4 to b3, which is right. So now we need to check if the pawn promotions actually work for black pawns. So in order to do this, let's try to change this white pawn to the black pawn to make sure it kind of works. So we now have g2, g1, queen, rook, bishop, and knight. And let's also try to replace this bishop. Let's try to replace which one in particular, the first one, this bishop with the pawn as well. So to make sure that e2 pawn is not moving anywhere, yeah, because there is a king. Yeah, well, perfect. So it seems like we did manage to generate quite pawn moves here, and yeah, this is the I guess I will just stop this video at this particular point. Yeah, so the next video we would be implementing pawn captures. So quiet pawn moves. So here we need just to say quiet black pawn moves, right? So this is kind of it. Yeah, in order to avoid you guys getting confused by this wrong commentary. So quiet black pawn moves here. So pawn promotions, all this stuff. Well, okay, so this is it for this video. Thanks for watching. I hope you've enjoyed and learned something interesting out of it. So the next video was supposed to be again like implementing pawn captures. So if you're interested, until the next time, and take care, guys.